Hello, my name is Viet Tran. I am a junior at UNC Charlotte, and today I will be giving my co-op presentation while I was working for TTI FLOOR North America. My title was just a cooperative education student for the electrical engineering team, and over the fall was my second term working with TTI. Our current co-op program is fairly new, and we're working on a rotation system between me and another co-op, where as of right now, while I'm studying at school, he will be taking my position and being as a co-op student. And I got to work with my manager, Dara Rickles. And just to give a small general overview, TTI FLOOR North America is a branch of the TTI brand, where we're working on developing just general products to aid the average American consumer in any sort of need. On the TTI Floor Care branch, we're focusing on, floor care. The major thing that we work on is developing vacuums for Hoover, Dirt Devil, and Auric, and our new commercial brands. So my main task as a co-op was to just learn how the design and testing process went, and to support that active product development. Right. So moving on, I wanted to approach my presentation sort of like the one that I was given at my company. At the end of my co-op term, I was asked to work on a single project by myself and present it back. So I'd like to show off that project and the technical aspects I got to work with it, and just more general other things I get to work with while working at TTI, and an insight on what my co-op experience was like. So moving on. As an electrical engineering co-op, there was definitely some expectations set. As a second term, I went through my first term as a design term, and so from here, it was moving on from testing to design. So the main goal, continuing to support any product development. Everyone is constantly working on their own projects to get different products shot out as fast as possible. If I was able to aid in any way in terms of testing or in the design work, that was my main goal. But since this was my second term, I still was looking more into firmware and hardware design, just to see which one really stuck with me, and just had to rely on my previous term, which was heavy testing term. So that's just a general overview of what my co-op was generally expected of me. So in terms of the technical side, my major project that I had to present is called the lightweight stick vacuum, and we call it Opal. It was just a nickname. We like to give little nicknames to each vacuum that we're setting up. So we have this product line called One Power. It's just a vacuum series that we're working on. So in that series, we were tasked with creating Opal in about 2022, and so to get an early start to that project, my manager Dara decided that I should try to tackle an engineering entry-level project of working on taking an existing board layout and then changing the circuit design itself, because we want to change the processor, because we were working with STM32, and just due to a number of factors, we had to switch out our microprocessor. It's the little processor to the right of that circuit board over there. And we also had to implement some lessons we've learned from other vacuums. So it was just a small level project of working on the firmware and hardware aspects and updating this unit and it was really just to set the early schematics and board layout for this project that would last for 2 more years. So as a co-op, they allowed me to actually design this board and set it, the initial one, so that I can pass off my project to someone else to do in the future. So most of the details here were for the company, just how I changed the microprocessor and how the blade was the original board that is the name of the original vacuum that this board was based on. And then we had an external programming system where we could port our code onto the board out through these little metal brass pins over there, if you can see to the left of the processor. So this is the actual board here, Opal, that I got to design, and then we ordered circuit boards for, and it looks a little sloppy, but I got to solder on the components on there, but it was a great deal of fun and very fun to design and work with in person. So, I have here the process that the work that I had to put in. On the left is the schematic of Blade, and on the right is my schematic for Opal. And it was just we were changing the processor pins because we were going from 48 coding pins to 32. So we had to figure out which pins could go where, and we're rearranging, and we're seeing which pins needed what capacitors and diodes to function properly. So it was just a lot of checking to our former schematic of what was working and trying to incorporate as much as we can when we're switching those pins. So I also got to work a lot in Altium. Altium's really fun, and it's really how you say energy draining. So when I was working with Altium, it was a great deal of just amazement to me, seeing how it goes from simple board schematic to this large scale circuit. So when I was working with Altium, in the photo on the top left is my rough draft of when I was working with Altium. The goal was to try to remove as much of that blue as possible, because I'm trying to fill it in with my ground plane, so that each component can reliably connect back to the ground, so there wouldn't be really any connection issues. So it was just all about playing around and moving around different components and seeing where it could fit where, and trying to make it as clean and nice as possible while following a general set guideline, a rule set. And then in firmware design, I was using a software called STM32Cube, and I was coding in ARM Kyle. On the left is the original Blade's 48 pin, and on the right is Opal's 32 pin. So we basically had to take each type of pin and their name and basically move them around until we could find a reliable place where the pin could actually perform its actual function. So it was a lot of checking the schematics of each and every single processor and figuring out if we could reliably change one processor to the other. And we even considered whether we can even do this, but we were just trying to check ourselves as much as possible so we could do this, and luckily we were able to. So from the design aspect and having my board ready and having the code ready and ready to shoot it into this board, we had to go test it. So sadly, I could not get the board ready in time, so we couldn't finish up to our testing, but we had a parameter set. We were going to set this vacuum up into a blade, and then measure the temperature of different electrical components to make sure that nothing was overheating, so we were passing UL standards. We were going to run it on multiple batteries and just check the heat that's going on, just to make sure that nothing could go awry. And then another system that we were testing was the external programming system. On the photo on the left is my programmer hooked from my laptop to the board itself, so that there's direct contact. So this is how we normally were doing our program, but it requires direct contact, and we have to open up the unit. So we have to spend our time and effort to open certain units that would take forever, or while the board's exposed, it's dangerous and it could actually short the board. So we got to develop the photo on the right here, a bootloader. So we it's basically through the battery ports able to connect back to the unit and to tell it to await coding instructions. So the board's not even the board itself is not exposed to the elements, and we could just directly do that, saving a lot of time and effort from any sort of shorting issues. So here's my spring term. It was mostly on testing, and it was a lot focused on just shadowing and seeing how things are done and running tests for myself, also seeing how others people perform theirs. And then we got to move on to this fall term, and it was a lot of review. What I mean by bootloading 120 units, Evolve is a type of vacuum that we were running. Bootloading was importing code into said units, and the power bank was just this new system that we were running where we could take a battery charger and charge phones in a need of emergency. And I was supporting UL development, and I also began a small mentorship program, and I got to do a lot of quality. And then back on that UL testing, the top photo on the top left is about like 56 electrical boards that I got to short, just to make sure that nothing on the boards could actively cause any danger to the vacuum or the user itself. And I got to go to Cookville, and the photo on the bottom left, we were running quality control. And then from there, we were running in November to December, beginning that Opal project and looking into circuit design and getting the board ready, and then having the firmware and trying to run the test, and then setting up the co-op program. So in terms of next steps, I still have another term at TTI. In a general sense of what we're trying to strive for, I still got to keep tabs of One Power Opal. It's projected to finish at 2022, so although someone else will be taking the lead design in the project itself, since I had early help, I'll be put back on that team to make sure that the project's running smoothly as we're going through the product development cycle. And previously, in my last project, I worked on a user error message project. So I had never got to implement it this term, so we're looking to implement that next term. And what this co-op program has really shown me, showing me the different aspects of hardware and firmware and testing, I've really gotten to enjoy hardware, and I've discussed with my manager, and we're going to push for that towards my next term. And the co-op program itself, as a retrospect, I got to explore a lot about electrical engineering, the different components and factors of it, and it's been really fun, and it's really enjoyable, and it's definitely taught me that I'm chosen the right major, and I'm enjoying myself by a great deal. And the co-op program itself, it's helped me meet these people at TTI. They're so welcoming, and I'm enjoying every single day of my co-op, and I feel so valuable to working with them. I cannot wait to return to my next term. They've taught me a great deal about work and life itself. They've helped me so much in my professional portfolio, and I am truly grateful to them, and I'd love to say thank you to them. The photo on the right here is me and Colin Hall at Cookville power plant, manufacturing plant, and we got to explore that together. And if anyone has any questions, please feel free to contact me at my email. Thank you so much for listening to my presentation. I hope you have a wonderful day.